Good afternoon, good evening, ladies and gentlemen. Welcome to another series of tutorials with me, Aubrey. If you haven't already, please subscribe to the channel, leave a like, comment, and share the lessons with other people. So this lesson is brought to you by Sydney. He requested that I do a video on this integral here. The question asks us to evaluate the integral 1 over 2 cos squared x plus 1 with respect to x. All right, so for this integral, we can use something that we know or we call the Weierstrass substitution. And the Weierstrass substitution is this substitution that is here. It says we can let x is equals to tan of k over 2, then cos x becomes 1 minus k squared over k, 1 plus k squared. And if we have a sine of x in the function, this becomes 2k over 1 plus k squared. And the dx becomes 2 over 1 plus k squared dk. All right, so this is a substitution. I'll do a video on the derivation of these three substitutions, but this is the Weierstrass substitution. But there are conditions that we need to follow for us to use the Weierstrass substitution. The first condition is that the cos function or the sine function should be in the denominator of the given integral. Then the cos function or the sine function should be linear, right? Should be linear. So as you can see here, our cos function is not linear. So we need to make this function linear before we use the Weierstrass substitution. So how can we make this linear? We're going to make use of double angles. So we know that cos squared of x can be written as 1 plus cos of 2x, then divide by 2. So this is more linear. We can replace in there. So now our integral is equal to 1 over 2 times, where there is cos squared x, we can replace that, which is 1 plus cos 2x divided by 2 plus 1, then dx like that. All right, so we simplify that. We simplify this. This becomes 1 over, we see that the 2 there and the 2 can cancel out. We remain with 1 plus cos 2x plus 1 dx. Then these will add up and we'll finally have 1 over 2 plus cos 2x dx. All right, so that is our integral. Now, is this yet linear? All right, it is somehow linear, but we should also have only one variable here as expected from the substitution. We should only have one variable there. So how can we have one variable in here? Okay, so we can have one variable in here by letting, we will let theta equal to 2x. So we should remember this substitution that we've made. So we will need to remember all the substitutions that we are making. So when we let x equals to theta, our d theta dx will be equal to 2, and our dx will be equals to d theta over 2 when we make the x subject of a formula. And replacing in this equation, finally our integral is equal to 1 over 2 plus cos, for 2x we're replacing theta, times our dx is d theta over 2. D theta over 2. We can simplify further, which is I equals to 1 over 2 integral of 1 over 2 plus cos theta d theta. Now we are in a position where we can use the Weierstrass substitution. So remember, we had x, now we have theta, so we can say we let theta equals to tan, sorry, we use the same. So we let, so let me see. All right. We let theta equals to tan of, we'll use x in, or we use k, the same k that we have, k over 2. Then we see that our cos theta will be equal to 1 plus k squared, 1 minus k squared, 1 minus k squared all over 1 plus k squared. And if we had sine theta would be equal to 2k over 1 plus k squared. Then our d theta is finally equal to 2 over 1 plus k squared dk. So this is the Weierstrass substitution. So we are using the Weierstrass substitution now. When we use the Weierstrass substitution, our integral finally becomes equal to 1 over 2 integral of 1 over, then we have a 2 here, plus where there is a cos theta, we can replace with 1 minus k squared over 1 plus k squared. Then we have our d theta, which is 2 all over 1 plus k squared dk. Okay, then we can now start simplifying this. Okay, we can now start simplifying this, but we have made 2 substitutions so far. That is what you should put in mind. The first substitution that we made was theta equals 2x, sorry. So theta is equals to 2x. We've also made the substitution v is equal to tan theta over 2. Okay, so don't forget that we've made these substitutions. So this is from the Weierstrass substitution, which is here. Okay, actually it's theta is equals to, let me erase this. So from the Weierstrass substitution, our theta, we've made the substitution theta equals to tan k over 2. So this is from the first substitution, and this is from the Weierstrass substitution. So we need to resubstitute those two when we are done integrating. So yeah, we proceed. So now we simplify this. Our integral becomes equal to, we have 1 over 2 out here. This times that, it will just be 2 all over with this times 2 here, that will be 2 plus 2k squared. Then this times this, we see that we have the same, the denominator and the numerator will be the same, so they will cancel out and will remain with 1 minus k squared. Will just remain with the numerator. Then we have our decay there. Then we see that this and that simplifies. Then our integral becomes equal to 1 over, down here we see that this 2 plus this 1, it will be 3. Then we say 2k squared minus, that will be just k squared. Then we have our decay there. All right, so we have our decay there. Then now from here, we can use trigonometric substitution to solve this. So we have our k squared plus, meaning that we're using the tan trigonometric substitution. So for us to use trigonometric substitution, this should be squared. Now, how can we introduce a square here? Okay, how we can introduce a square there, we can rewrite this as integral of 1 over 3 to the half then squared plus k squared dk. Now we can use trigonometric substitution. This has to be squared, and we're not changing anything because this times that will just be 3, and we need to make sure that the coefficient of k is 1. So if there was a number here, we would have factored it out. So that is what we should put in mind when using trigonometric substitution. All right, so we have that. So for trig substitution, your k is equal to a tan theta. That is your k. So in this case, our a, this is our a. This is our a. What is inside here is our a, and this is a equal to 3 to the half. 3 to the half. Okay, I recommend that you already know how to use trigonometric substitution. So I would make more lessons on trigonometric substitution, but that is our a and that is our k. So yeah, so our k now is finally equal to 1/2 tan theta. So now we can replace in this integral. So I will be equal to integral of 1 over, this is our a, which is just 3. So this 3 to the half squared plus our k. Our k is equals to this now, which is 3 to the half tan theta. Then everything is squared. Then we also need to find decay d theta so that we have theta everywhere. So decay d theta, when we differentiate this with respect to theta, what we're going to have is 3 to the half sec squared theta. And making decay subject of the formula there, decay will be equal to 3 to the half sec squared theta d theta. All right, so meaning that in this integral where there is decay, we can replace with times 3 to the half of sec squared theta d theta. Again, we can replace with that. Then here we start simplifying now. So we see that this is just the same as 3. So this is just 3, and that would be 1 over 3 plus we distribute the power, that will be 2 to the this, it will just be 3, then 2 tan, it will be just tan squared theta. Then on top we have 3 to the half sec squared theta d theta. Okay, our integral is now equal to, so this we can factor out the 3 here. So we have on top we have root of 3, which is 3 to the half. We factor that out as well. Then over down here we just have a 3. Then we have integral of 1 over 1 plus tan squared theta. Okay, we can write, the numerator can be written as sec squared theta because we have that. So it will be sec squared theta d theta. Okay, which is that. Then we simplify this. So this becomes equal to, so bases, adding, subtracting powers, this would be 3 to the negative half. Okay, then we know that 1 plus tan squared theta is just equals to sec squared theta. So we can replace with sec squared theta over down here, it will also be sec squared theta d theta. Then this becomes equal to 1 over root of 3 here. Then this is integral of 1 because this will simplify. with respect to theta. Then we are going to have I equal to 1 over root of 3 theta. Okay, so that is that. Then for theta, we know that theta is equal to, when we made a trig substitution, so we start with the trigonometric substitution part, we had k is equals to this for the trigonometric part. Trig substitution, we had k is equals to this, we had k equal to that. So from our trigonometric substitution, k was equal to 3 to the half tan theta. Then when we take everything on one side there, that would be k over 3 to the half, that is root of 3, will be equal to tan theta, making theta subject of a formula. Theta will be equal to tan inverse of k over root of 3. Okay, so that is what we have for our integral. I will be equals to 1 over root of 3. Then our theta is equals to that, so that it is tan inverse of k over root of 3. But remember that k, when we go back, k is not in our original answer. All right, k is coming from this. Okay, so we can make k subject here. If we make k subject here, we see that, wait, where is the substitution? Okay, if we make subject k here, we see that k over 2 will be equals to tan inverse of theta. Okay, we see that k over 2 will be equals to tan inverse of theta, meaning that k is equal to 2 tan inverse of theta. That is what k is. Okay, that is what k is. K is equals to tan inverse of theta, and theta is equals to 2x. So now k will finally be equal to 2 tan inverse of, where there is theta, now we can replace with 2x. So now we can replace k with this. So that will be k. Go down here. K was equal to 2 tan inverse of 2x. Okay, that is our k from the first step here. So k is equals to 2 tan inverse of 2x. So that is our k. So now we can replace k here, meaning that our integral is equal to 1 over root of 3 tan inverse of k, which is 2 tan inverse of 2x, then divide by root of 3. And that is our final answer. So if you have any questions, leave them in the comment box, and I will be able to respond to them. But for now, let's have a good day.